Section 3.1, Derivatives of Polynomials and Exponential Functions. We have seen how to interpret derivatives as slopes and rates of change. We have seen how to estimate derivatives of functions given by tables of values. We have learned how to graph derivatives of functions that are defined graphically. We have used the definition of a derivative to calculate the derivatives of the functions defined by formulas. But it would be tedious if we always had to use the definition. So in this chapter, we develop rules for finding derivatives without having to use the definition directly. These differentiation rules enable us to calculate with relative ease the derivatives of polynomials, rational functions, algebraic functions, exponential and logarithmic functions, and trigonometric and inverse trigonometric functions. We then use these rules to solve problems involving rates of change, tangents to parametric curves, and the approximation of functions. Now, in this section, we learn how to differentiate constant functions, power functions, polynomials, and exponential functions. Now, when we're dealing with constant functions, let's start with the simplest of all functions. The constant function f of x, which is equal to c. The graph of the function is the horizontal line y is equal to c, which has slope 0. So we must have the f prime of x, or the derivative, is equal to 0, as we can see this figure here. So a formal proof from the definition of a derivative is also easy. If we have the f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Well, the function is a constant, so it's c minus the value of c, which becomes 0 over h. So therefore, it's the limit as h approaches 0 of 0, which is equal to 0. So therefore, there is the graph to show the fact that this is the derivative of a constant function. So the derivative with respect to x of a constant is equal to 0. Then we have power functions. We next look at functions f of x is equal to x to the power of n, where n is a positive integer. If n is equal to 1, the graph of f of x is equal to x is the line y equals x, which has the slope 1, as you can see this figure here. So the derivative with respect to x of x is equal to 1. The definition for 2, the derivative with respect to x of x squared is equal to 2x. The derivative with respect to x of x cubed is equal to 3x squared. And 3, the derivative with respect to x of x to the fourth is equal to 4x cubed. So this gives us the power rule. What it states here is that if n is a positive integer, then the derivative with respect to x of x to the n is equal to n times x to the n minus 1. So let's look at these examples again, starting with from number 2. So if we want to find the derivative with respect to x of x squared, well, that's going to be the value of n. So what is the value of n? Well, the value of n is equal to 2. So we're going to have 2 times x to the 2 minus 1, which gives us 2x. Now, if I wanted to find the derivative with respect to x of x cubed, okay, now n is equal to 3 here now. So that's going to be 3 times x to the 3 minus 1, which is equal to 3x squared. And then if I want to find the derivative with respect to x of x to the fourth, then again, using the power rule, we know that n is equal to 4. So this would be 4 times x to the 4 minus 1, which would equal 4 times x cubed.